In this lecture, we're going to go over debugging your ROS code and setting up VS Code to do your compiling. So let's start off with debugging. So I'll open up VS Code, and here I have our publisher code from the previous lectures. I'm going to go ahead and comment out the line which creates our publisher. So even though we no longer create our publisher, the C++ linter doesn't even notice there's a mistake. Let's try to compile this code to see what happens. So I'll go ahead and save the file. I'll open up a terminal, change into our workspace directory, and I'll run build. And we see it compile successfully without any errors. But now let's see what happens when I try to run the node. Here we get a segmentation fault. Now, this is hardly helpful to us at all. Our code doesn't notice any errors, our compiler doesn't notice any errors, but something is obviously wrong. Yet, all we get is this segmentation fault error that tells us nothing about where the error is. This can be pretty frustrating, so let's learn how we can better debug our ROS code. The first thing we need to do is build our workspace and set some debugging CMake arguments, which we can do like so. So go ahead and hit enter. Alright, successfully compiles again. And now we can use a popular debugger called GDB when we run our node. There are a couple ways to do this, but I'm going to use GDB server to connect with our VS Code instance. So it'll actually show us exactly where in our code editor the error is occurring. So we can do that with the same command we used to run the node, but this time add a prefix with the GDB debugger info, which I'll just set to localhost port 3000. So by default, you may not have GDB server installed, so we can go ahead and install it now if you get the same error that I do. So I'll go ahead and clear the screen, and I'll go ahead and update our repositories. Put in your password, and then we can do apt install GDB server. All right, that's it. I'll go ahead and clear the screen, and we can try rerun our ROS2 command with those prefixes of running the GDB server. So here we see processing our node, listening on port 3000. But now we need to configure our VS Code to communicate with the debugger. So if I head back to our editor, we can head over to the .vscode folder and create a new file called launch.json. Here we will set up our debugger with the following code. You can find out more information on VS Code's documentation page on debugging. Then for the program section, you are going to put in the directory which your executable is located. So if you remember from previous lectures, if we go into our workspaces folder and we go into the install section, into our package, lib, package name, this is the location of our executable. So I can go ahead and get this parent folder directory. So I'll go ahead and copy that, paste it here. And we will be calling the publisher executable. All right, that's a bit long. Essentially, all we're doing here is configuring the C++ debugger to the same address that we are running our GDB debugger, and we set the location of our node executable, which is within the install directory of our workspace. So now I'll go ahead and save this file and head back to our C++ file. Then I will go over to Run and select Start Debugging. So see here, we see a bunch of text heading over to the screen, and here we see the exact line where the segmentation error has occurred. So we see an exception occurs when we're trying to publish our message. What's also cool about this is we have these windows on the left here, which show us what variables are in use and what are their current values, as well as the call stack down below. So already we are off to a much better understanding as to what could possibly be wrong in our code. It obviously has something to do with our publisher not being able to publish the message, which can lead us to conclude that something is either wrong with the publisher itself or the message is invalid. So I can check out in this left panel under the variable section. So messages higher up here, so I'll go ahead and click on that, and I'll go ahead and expand these. I'll go ahead and expand this window just a little bit. And so here we actually see the contents of our message. It was hello world 0 in a string format. So all of this seems valid for a message, so let's try check out our publisher variable. So I'll go ahead and scroll this down, and we'll check out this, down to publisher. And notice we don't really see much information about our publisher. We don't know what topic it was trying to publish to or the QoS configuration. So this may give us the hint that something is wrong with our publisher. Specifically, we never actually initialized it. So for now, I will stop the debugging by hitting the red square on the debug panel. This will float along the top. I like to move it over here to the side so it's not blocking any of my file tabs, but I'll just go ahead and hit this red stop button. And this will stop our debugger. And here in the terminal, we can see the ROS2 run has concluded. And we see we actually had connected to our remote debugging from our VS Code session. So now I'll go ahead and close this debugging window. I'll go back to our File Explorer, put this back to the way things were, and I can go ahead and correct my issue, which in this case was just not running the create publisher command. I'll go ahead and resave it, and I'll go ahead and recompile our code. I'll just go ahead and hit the up arrow to get the commands we got earlier. And we'll go ahead and run our debugger again. So it says listening on port. We'll go ahead and reopen our debugger. And notice no terminal windows are popping up checking anything. And that's actually because nothing's really going wrong with our instance. So no exceptions are popping up, and I can actually go ahead and open a new terminal and type in ROS2 node list. And we can see our node is successfully running, and I can go ahead and actually echo the values like so. And we see the hello world messages publishing to the screen without any issues. So that's why nothing's getting triggered on the debugger end. So for now, I'll go ahead and stop this, which will stop our debug instance. And in this case, it actually opened the file which it was currently running our debugger on. I'll go ahead and close this, and I will stop the debugger. All right, so hopefully you can see how configuring our build task and using our VS Code debugger can help us when we run into issues with our C++ code. Now, there's another important flag we can use with the build command called symlink install. Normally, when you run build, all your build files are generated in the build directory, and any relevant files ROS wants to organize are copied to the install directory. This includes things such as our compiled nodes from our build folder, and later we will see it copies our custom interface declarations and launch files. If we head over to the build folder, so I'll go ahead and open this up, go back to our workspace, go into our packages directory, and we see the executable we just ran among all these other files. But just as we saw earlier, if we head over to the install directory, that same executable is in a second location. So it literally had to copy the executable from the build folder to this directory. If I go back a directory and go into the share folder, and then into our package folder, this file is an exact copy of our package.xml file from our package that's in the source folder. So every time you would run build, it searches for changes in these files and copies them over. Now, this is fine in most cases, but there may be times where you want to edit a single file, such as your package.xml, without having to rebuild the entire project. Well, that's where the symlink install flag of build comes into play. Using the command, we will instead create links to the source files rather than copying them. Now, to make sure this gets incorporated properly, we will need to delete our current build, install, and log directories within our workspace. So if I head back to our workspace, I'll just go ahead and highlight them, and I can just hit delete. And we see those folders were deleted. Now I can go ahead back into my terminal. I'll go ahead and clear the screen and rerun build with the symlink install flag. Now we get this warning saying it was unable to source our workspace, and that's because we just deleted some of the files, but you'll see that it'll take much longer than usual since it is building everything from scratch, but eventually it will finish successfully. And close this, and now if I go back to the install directory, so it's regenerated all folders, go to install, back to our share. Now we see the package.xml file, the icon has an arrow on it, which shows that this is a link to the file. We can also see the same thing for our executables. So here we see this is a link to the publisher executable, which is in our build directory. If you want to see where the location of the source file is, you can use the readling command in terminal. So for example, let's check that package.xml file. And here we see the source file is indeed from our package in the source directory of our workspace. So any changes we made to that file will automatically be made here, which again will come in handy later in the course when we start working with custom interfaces and launch files. And just to prove to you further that this works, we can go into our lib folder. And here we see our publisher executable. So if I do that same command, we see this link points to our build folder. Now, in this lecture, I've shown you two ways which you can configure build to help with symlink installing items and debugging. Now, it can be hard to remember these exact lines, and it seems a bit of an inconvenience to have to open a terminal, go to our workspace directory, and run build every time. So instead, let's configure our VS Code to build our code for us. To do this, I'll go ahead and minimize my terminal. We'll head over and the File Explorer. We will head over to the .vs code directory and create another new file called tasks.json. As usual, you can find more information about tasks on VS Code's documentation page. So here, all we are doing is mapping the build symlink install command to the build label task in VS Code. And we specified that these commands run in the shell. Notice that I sourced my ROS installation before building. That is because by default, the VS Code shell does not source our bashrc file in our home directory. So we have to manually specify to source the ROS installation, or alternatively, you could change this to source your bashrc file. Then I use two ampersand symbols, which specify to run the next command if the first one is successful. Now I will create a second task, which will be responsible for building with the debug CMake arguments. Now this covers our compilation, but we still need to run our node within the proper prefix argument. So I can make a note of it by printing a message to remind me about the prefix and to modify the launch.json file to look at the correct executable. Now I know this is a really long, but unfortunately we can't break up strings by line in a native JSON file. So the alternative is that you could put this line in a separate bash script somewhere on your computer and just call that bash script here. But here we're just echoing the message and using \n to create new lines in the terminal so that the command will be formatted nicely. If you feel like you're making a typo somewhere, don't worry, I will include these JSON files in the resources section so you can use it for reference. As always, be sure to save the file. And now if we head over to the terminal toolbar tab, there's an option called Run Build Task. This will run our task which we labeled build. So let's go ahead and try it out. And here we see it started building our workspace using the commands we told it to do. Please note, if your VS Code is not open to your workspace folder, you will be running build in the wrong location. So be sure to either open VS Code in your workspace folder or within the command attribute, be sure to navigate to the directory using the cd command before building. So now with one button, we've gone ahead and run the build command with the symlink install flag so we don't forget it. We can close this terminal by hitting any key. So I'll just hit spacebar and it goes away. Now we can try our debug task by heading over to that same terminal tab and heading over to run task. And here we can see our build task and our debug task and some other pre-generated tasks that we can run. So let's try out our debug task and we'll just continue without scanning. And so just as before, another terminal window pops up with our command running. So now it is compiling our workspace with those debug CMake flags. All right, so now we see it compiled and we see it run the node using the following prefix and it gives us the command for us. Now I actually just noticed that GDB server localhost 3000 is not in the correct quotes because we are actually using a single quote here when echoing it. So all I have to do is use a double quote instead, which I will use a backslash key for to escape out of it so it doesn't get mad with how many quotes we're using here. And I'll go over to the end of this echo command and do the same thing. So I'll replace this single quote with a backslash and a double quote. And now I believe we should be just fine. So now if I go ahead and save this file, and we will run task, rerun our debug task one more time, we see it prints to the screen correctly. So it says ROS to run prefix and GDB server localhost in single quotes. And the really cool thing is it says here, and modify the execute path in vscode.launch.json. Now you'll actually notice if I hover over this, a little window pops up and I can open the file in editor. So if you ever forget where this is in location, VS Code will automatically open this for you. And here you could change the program here to be the executable that you're trying to run. So if you have a different node name, you would simply change this name at the end. All right, enough of that. I'll go ahead and close this. Last thing I want to cover are a couple of ROS commands you can run in VS Code using the ROS extensions. So if I bring up the command bar by hitting the F1 key on the keyboard and type in ROS, we can see a series of commands we can use, most of them related to the ROS extension we installed. We've already seen show status, but I'll go ahead and open that up right now. So here we just see our ROS2 daemon in the background and some background topics. Then I will hit F1 again, type ROS again, and we can see some other options. Some of these commands should sound familiar, like running a ROS executable. Notice in parentheses it says ROS run. That's because this was the command to run nodes in ROS1. So even though we have configured our ROS extension for Humble, it doesn't update this command list unless Microsoft doesn't update in the future, which would be cool. So I can go ahead and click on it. And now we can select a package. So I'll scroll all the way down to our Udemy ROS2 package. So it automatically sourced this environment for us. And we can see we can choose an executable. In this case, all we have is our publisher. So I can go ahead and click on that. And if we had any extra arguments, we can put that in. We don't have any, so I'll just go ahead and hit enter. So we see a terminal pops up and it goes ahead and runs the ROS2 run command. And we now see our hello world topic being published to, as well as the services related to the node that was started up. So I can go ahead and hit F1 again, type in ROS. Here we can see we can also create a ROS terminal. All that really does is open a terminal and ensure it's sourced to your ROS installation based on what your extension settings are. So I can go ahead and open that. And here we see a new tab has appeared and we have multiple terminals. So here I can run ROS commands like we normally do. For example, echo the hello world topic. And here we see the messages echoing to the screen that we are publishing from our other terminal tab. For now, I'll go ahead and stop this with Control C. Then I can head over to the right and delete these terminals by hitting the trash icon next to them. Going back to ROS commands, I'll hit F1 one more time, type in ROS. We see things like ROS start and stop. That was mainly important in ROS1, where there used to be a ROS master server you needed to start before running any nodes. Now it's managed by the ROS daemon in the background, but for the most part, you shouldn't need to touch it. Another cool command is the install ROS dependencies with ROS dep. This is useful if you download a ROS package from GitHub instead of installing it with apt install. You can have ROS dep install any additional dependencies of that package onto your computer if you don't have it. Then another command which may be of interest is the ROS update C++ properties. This will automatically configure your VS Code C++ extension for any ROS packages and distros it detects. So luckily, it did that to us in the very beginning automatically since it knew we were developing in a ROS workspace. And for now, I'll go ahead and close this ROS2 status page. The last thing I want to mention is that all the lectures in this section will have downloadable content, which in most cases will be a zipped folder with the entire package solution code for the current lecture. So if you ever run into any problems in this section, you can always download the zip file. So for an example, I've gone ahead and downloaded the zip file that's meant for this lecture, so compiling rosnodes.zip. So all you have to do is unzip it. I'll just go ahead and extract here. And so now we have this compiling ROS nodes folder, and if I go into it, we see the Udemy ROS2 package. So I can take this folder, I can go ahead and copy it, go into workspaces, and we can actually create an entirely new workspace for when you're debugging. So we'll call this debug WS or debug workspace. Create a source folder and paste in the package which you've downloaded from the resources section. Now you could go ahead and compile this to ensure everything works as expected. So you can head over to this debug workspace and compile the solution to see if you are still running into any problems. If it compiles fine, then it most likely is a typo in your code, or you have not configured your cmakelist.txt file properly. So you could just go ahead and compare your files with mine side by side. So for example, I'll just go ahead and open a new window, and I will open that new folder that we just created. For example, you could compare my publisher code to yours by just putting these side by side. And you could even minimize the file tree so that you could see this better. So I'll go over to the publisher.cpp, and now you can check your code against mine using the content in the resources section. If you ever get stuck, feel free to use the Q&A section at the bottom of the video to ask for help. Just be sure to send screenshots or any errors, as well as the code of interest and the cmakelist text file. Well, that was a lot to take in, but hopefully now you know how to set up your VS Code workspace to compile and debug your ROS code, and now have a bit of insight into some of the commands in the ROS VS Code extensions.